What's up, everybody? Welcome back to the Scalar Learning weekly live stream video on SAT prep. And I'm so sorry, we were supposed to release this video yesterday. As per usual, we release it every Monday. So I'm so sorry we have to release it on Thursday. We just weren't able to fit it in. Now, we're going to get going here very shortly. I'm just making sure everything is going smoothly from the live stream standpoint. Make sure yep, we got audio coming through. Everything is good. Just got to make sure that's all good. And now let's go back to the test. I got it all set up. So guess what? This is the end. This means we've gone through every practice test on Khan Academy. This is practice test number 8, and this is the calculator section. So we are finishing it up right now because there's only 8 available. I'm sure there'll be more soon. Let me load up a calculator here and have that prepared, and we're gonna get started very shortly. Calculator. All right, boom. I just used the Google calculator, and without further ado, let's get it going. Sorry, I just moved. That's why there's all these boxes everywhere, so it looks a little crazy right now. The lighting's not good, but we'll get back to the whole all good setup next week. 38 questions, 55 minutes total. As I always say, I'm doing these questions for the first time. That's part of the fun, so you get to see me actually go through the process and still explain as well, but we are under a time crunch, so it's going to mimic real life test surroundings. So without further ado, let me take this off. Without further ado, let's begin. All right, continue the first question here. All right, 1 pound of grapes costs $2. It's just 2 times C. C pounds. All right, I'm not even gonna go into that. $2 for every pound multiplied times the number of pounds. Tracy sells and trades figurines, and she tracks the number of figurines in her collection on the graph below. All right, on what interval did figurines decrease the fastest? It's right here where it's dropping at the steepest rate. So it's only dropping here and here, and this is from months 3 to 4. In a random sample of 200 cars of a particular model, 3 have manufacturing defect. At this rate, how many? So look, we can just set up a ratio. We're just like a proportion. We're like 3 per 200 have a defect equals X out of 10,000. Right? We need to figure this out, right? So we just cross multiply. We get 30,000 equals 200X. Divide by 200. Divide by 200. You could use a calculator if you want, but you can kind of cross off some zeros. It's 300 divided by 2, which is 150. So a little faster in that case, I think, not to use a calculator. Next, dimensions of iris petals and length. So dimensions of the petals and the length in millimeters. Oh, I'm sorry. This is the width in millimeters and the length in millimeters, and what's the relationship? The scatter plot shows data collected on the lengths and widths for these petals of this flower. A line of best fit for the data is also shown. Based on the line of best fit, if the width of an iris setosa petal is 19 millimeters, it says based on the line of best fit, if the width is 19, here, somewhere, something like this, I think it would be here. What is the, no, sorry. If the width is 19, yeah. If the width is 19, the predicted length is, so we just take this straight up, and the predicted length is right here, which should be like 52.5. 52.83 is the closest, so I'm going to go with that. Be careful with the line of best fit. You don't look at data points, you look at the line of best fit only. All right, in the figure above, lines L and M are parallel. Let's redraw this. On the real thing, you don't have to ever redraw because you can write on the actual sheet. I just don't have that luxury. L, M, these guys are parallel. And we've got X, oops, let me undo that. We got X, Z, and Y. And it says in the figure of, and Y equals 20, Z equals 60. Y equals 20, Z equals 60. What is the value of X? Got it. All right, let's figure this out here. So we got 20. Let me just erase the Z and the Y. What other information do we have? We have that. Oh yeah, sorry. So see, let me move this closer here. So we're gonna use some triangle rules, of course. 20. This angle is also gonna be 20 because it's the same. These are corresponding angles. So 20, 60. So X is 100. Why is X 100? Because 100 plus 20 plus 60 is 180. So they all have to add up to 180. Oops. Back to question 6. Two types of tickets were sold for a concert held in an amphitheater. Tickets to sit on a bench cost 75 for bench, and lawn costs 40. They announced that 350 tickets had been sold. This is a system of equations. 350 tickets have been sold, so that means bench plus list equals 350. The total tickets have been sold is that, and that this had been raised, this amount had been raised, which means if we take the cost 75 times the number of bench plus, what is it, 40 times the number of L, we get a total money of 19,250. Which of the following systems could be used to find the number of tickets? B, the number of lawn tickets. So all we got to do is, there's a system of equations, I just wrote them out. Which one is it? This is not right. They're multiplying each other. They're supposed to be adding. This looks right. It's backwards though. They put 40 for bench and 75 for the other one. 75 for bench, that's right. 40 for this one, and B plus L equal. Nope, but they switched these numbers. And 75 bench, 40 L. This is our equations. This is exactly what we have. In the xy plane, the graph of which of the following equations is aligned with the slope of 3? All we got to do is make sure x is isolated and that the 3 is multiplying the x. Hopefully you know y mx plus b. It's this guy, simple as that. You know y equals mx plus b, you can solve that in 5 seconds. X plus 1 equals this. Which of the following is a possible value of x plus 1? This is actually a quadratic form equation, believe it or not. So we're going to just simply try and isolate x. First, we're going to multiply both sides by x plus 1. Both sides by x plus 1. These cancel out. 2 equals x squared. I'm foiling now, like this. 2, so it's 2x plus 1. Subtract 2, subtract 2. X squared plus 2x minus 1 equals 0. And I'm going to factor it and see if it factors. And it doesn't factor. I can already tell. X, nothing multiplies to -1 and adds to 2. So we got to use the quadratic formula. Oh, wait. So this is a good equation. But now what's the quadratic formula? It's negative b, which is 2, plus or minus the square root of b squared 4 minus 4a, which is 1, and c, which is -1, over 2a, which is 2 times 1. And then it's -2 plus or minus the square root of this becomes, these cancel out to become a positive, right? So it's 4 plus 4, which is 8, 2 square root 8 over 2. We can simplify that, 8 to be 2 plus or minus 2 square root 2. We're pulling out a 4 as a 2. I'm kind of having to do this fast, I apologize. I got to make sure we have time at the end. And then divide these both by 2, becomes 1 plus or minus square root of 2. And oh, but they want x plus 1. So we got to add 1 to this. So it's 2 plus or minus square root of 2. Which of the following is a possible value of x plus 1? Wait a minute. 1 square root of 2. Oh, hold on a second. X plus 1. I'm actually gonna go with. Did I miss something? Oh, that -2 is negative. It's a -1. Sorry. So these guys cancel out. It's not 2. It's plus or minus square root 2. Whew. All right. I was confused there for a second. See, I messed up with the. I forgot to carry over the negative. Just a simple mistake like that. But I was able to realize that it didn't work. Or the answer I thought was gonna be there wasn't there. So I reevaluated and figured it out. All right, next we've got this thing. There's the volume of this guy, and they gave us that equation. The glass pictured to the left can hold a maximum of 473 cubic centimeters, which is 16 fluid ounces, right? Oh, that's K over 2, and that's K, and that's K. What is the value of K in centimeters? So we're just going to have to plug it in. 7 pi K cubed over 48 equals, what does it say? How much does it hold? It holds, where did it say how much it holds again? Oh yeah. So are we doing this in, K is in centimeters? Let me see. I assume, it doesn't say what the units are. Okay, I'm assuming this is in centimeters. Okay, so if we do this, what is this in? Yeah, it's in centimeters. So we're going to use the cubic centimeters value. All right. Oops, computer's making a weird noise. All right, we're going to have to use a calculator. First, multiply both sides by 48. 473 divided by 48. I mean, multiply by 48. 473 times 48 equals this. 22704. 22704 equals 7 pi k cubed. Divide by 7. Divide by 7. Divide both sides by 7. 3243.4. 3243.4 equals pi k cubed. Divide by pi. Divide by pi. And we get this. And then I'm going to take the cube root of this, of both sides. Now we've crossed this out. Cube root of this, and we'll get k. So then we say, where is it? Actually, I'll just raise this to the 1/3 power. That is the cube root. Oops. 1/3 power is 10.1 roughly. 10.11. Yeah, that's right. See, if you round it up, it will work. Okay, now water pours in the glass slowly at a constant rate. Which of the following graphs best illustrates the height of the water level in the glass as it fills? Well, let's look at the glass. The height's gonna it's gonna fill up faster at the bottom because there's less area to cover, and then slowly it's gonna slow down, right? So it's gonna start faster and then slow down. This is wrong, right? This shows an acceleration. This shows constant. That's wrong too. It's going to go like this. It's C, right? It's gonna start really, really fast and then slow down, slow down, slow down. Okay. Wait, why did they skip to question? Did I not select it? Hold on. 10.11. Yeah. Oh, there's an 11. Jenny has a pitcher that contains 1 gallon of water. How many times could Jenny completely fill the glass with 1 gallon of water? So it's 128 divided by how many fluid ounces was it? 16. 128 divided by 16. 8 divided by 16 equals 8. That's it. Okay. Roberto is an insurance agent who sells 2 types of policies, 50,000, 100,000. I'm guessing this is a potentially 6 system of equations again. 50,000 and 100,000. Last month his goal was set to sell at least 57 insurance policies. While he did not, so we'll say x plus y equals, what is it, 57? The total value of his policies he sold was over 3 million. So he sold less than this. But we have 50,000 x plus 100,000. Y is greater than 3 million. System of inequalities, I guess. Describes x and y. So you see, I've already kind of anticipated x was going to be the smaller one. Usually you should read everything first. I guess I kind of anticipated it and was correct in the way I set it up. Even if I was wrong, it wouldn't be that big of a deal. But look, we got x plus y is less than 57. That's correct. 550,000 x was 100. It's not this one because it's less than. We have said over 3 million. That's wrong because this is wrong. This is right. It's got to be this one. It's this one, right? It's exactly what is written over there. Next, a to the negative 1/2 equals x, where a is greater than 0. What is a in terms of x? So we got to isolate this. First of all, a to the negative 1/2 is 1 over a to the 1/2. And this means this is 1 over the square root of a equals x. Which means now we want to isolate a basically. I'm just going to multiply a over here. We got 1 equals x square root a. Divide both sides by x. Divide both sides by x. And then we got the square root of a equals 1 over x. And then I'm going to square both sides to get rid of that square root. And we got a equals 1 over x squared, which is this. Negative 3 over this guy. All right, first thing, where is it undefined? First thing you're gonna do, I say you see a quadratic, just factor it. That's the instinct that you should always follow, and that will actually give you your answer here. So we have to think what multiplies to -10, adds to 3, +5 and -2. Now, why did we factor? Why does it matter? Because it actually helps us to see where we get zeros in the denominator, because you divide by 0, it's undefined. So we have a 0 at x equals 2 and x equals -5. 2, here we go. There's one of them. A granite block in the shape of a right rectangular prism has dimensions. Oops, I'm going to draw it out immediately. Like this. 34, let's say this one's 50, this one's 40, I don't know. Doesn't matter. The block has a density of 2.8 grams. Oh, and these are all centimeters. 2.8 grams per cubic centimeter. So what is the mass? So all we got to do is find the volume and then multiply it by 2.8. Find the amount of cubic centimeters. So it's literally this: 30 times 50 times 40. 30 times 40 times 50. Now you can use a calculator if you want. You can also do it in your head. This is 12, and then 12 times 55 is 60, and then you add the 3 zeros: 1, 2, 3. Right? And so it's 60,000 cubic centimeters, and then we multiply this times, wait, why are you giving such small values? Yeah, 60,000 times 2.8. It's got to be this, but let's actually use the calculator just to double check. Times 2.8 is 168. So there we go. Boom. Question number 16. The table shows the results of a research study that investigated therapeutic value of vitamin C in preventing colds. A random sample of 300 adults received either vitamin C pill or sugar pill each day, and the adults reported whether they contracted a cold. What proportion of adults who received a sugar pill reported contracting a cold? What percentage did it say? Oh, what proportion? It's a proportion of adults who received a sugar pill. So it's 33 out of 150. That's it. We could simplify this by divide both by 3, and it's 11 out of 50. If that's what they're showing it as. Yep. And that's it. Sweet. Ages of 20 students enrolled in a college class. Which the table shows the distribution of ages of the 20 students enrolled in a college class. Which of the following gives the correct order of the mean, median, and mode? So we want mean, median, and mode. So let's figure out what those are. Alright, I don't think you actually have to calculate this, but look, how many is it? 20. So we can figure out where the mean is. The mean is gonna, the median. The median's gonna be 19, because you can see that the halfway point's actually between 10 and 11. So you have to take the 10th and the 11th value, average them, and I can already tell the median is gonna be 5. The mode is clearly 6, because that's the most frequent one. And then the mean is, let's see, the mean is going to be on the lower side, because, no, I'm sorry. Oh, what am I doing? I chose the frequency, not the, sorry, the mean is 19, that's what I meant. The median is 19, because it's going to be at the 19. The mode is going to be 18, and the mean is going to be, it's definitely going to be higher, because we've got the other values skewing it up, and we've got more things greater than 20 than less than 20 overall. So it's going to be above 19. So the mean's going to be the biggest, then median, then mode. Mean's the biggest, then median, then mode, this guy. So I don't think you actually have to calculate it, but you can if you want. You could add them all up and then divide by 20. All right, 11. Yeah. The mean's going to be over 19. All right. Next, the figure below shows the relationship between percent of leaf litter mass remaining at decomposing for 3 years and the mean annual temperature in degrees Celsius. In 18 forests in Canada, a line of best fit is also shown. Cool. A particular forest in Canada's data is not included in the figure had a mean annual temperature of -2 degrees. So like right here somewhere. Based on the line of best fit, which of the following is closest to the predicted percent leaf litter mass remaining in this particular forest after decomposing for 3 years? So this is this for 3 years? Yeah, okay. So -2, I'm going to just bring it right up here. So that's like 67.5 or something. Wait a minute. This is 2.5. Here's -2. It's like, ooh, wait a minute. It's 63 and 70. It's like in between those. All right, let me read it again. Had a mean annual temperature of this, as closest to the predicted percent of leaf litter mass. Percent of leaf litter mass remaining, decomposing for 3 years. And then, is there anything else? Why is okay? Let me see. 5. Oh, wait a minute. No, this is -5. This is -2.5. This is -2 right here. I didn't read that correctly. Yeah, so it's 70%. There we go. 19. The range of a polynomial function f is the set of all real numbers less than or equal to 4. So it's 4. Yep, because 4 is like the top. That's the y values. If the zeros are -3 and 1, which of the following could be the graph of f of x in the xy plane? Oh, this is not necessarily it, but yeah, it does have to be less than 4. This looks right. And the x and y, the zeros are -3, which looks right, and 1. I'd say it is A, but let's look at these other ones. 4, the zeros are wrong. That's 3 and -1. The zeros are right, but it's the range of up to infinity, yeah, and that's wrong. So it's definitely A. The average annual energy cost for a certain home is that homeowner plans to spend $25,000 to install that. The homeowner estimates that the average annual cost will then be lower, which of the following inequalities? We saw to find T, the number of years after installation in which the total amount of energy cost savings will exceed the installation cost. So it's like 4,334 times x. When will this be greater than 25,000 plus 2712 times something like this? And oh, they did it a little differently because they isolated. Hold on, let me see what they did. All right, so what they did. This equation is correct, but oh wait, are they saying when this will? Yeah, okay. So what they did was, I'm gonna try and see if I can sort this out. They just basically isolated these, so I'm gonna subtract, because it's the same thing that they do this sometimes. We have to do a little extra work to make sure the equations match up. So I see that 25,000 is often isolated, so I'm gonna isolate 25,000 like this. Is less than or equal to 4334 minus. And what they did also is they factored out the x. And it's 25,000 is less than, yeah, it's this one. See, when you do that, that's right. 25,000, what else is this? They subtracted 4. No, this would not be right. And yeah, I don't even know how they would get D. D is completely wrong. So let's roll with that. 21. See, now we're getting into the harder questions. Between 1985 and 2003, data were collected every 3 years on the amounts of plastic produced annually in the United States in billions of pounds. The graph below shows the data and a line of best fit. The equation of the line of best fit is that, where x is the number of years since 1985, so 0 is 1985. Y is the amount of plastic produced annually. Which of the following is the best interpretation of the number 3.39 in the context of the problem? It is the slope, which means that it's the amount of billions of pounds every year that is increased. That's all it is. That's the slope. It's the change over time, change over x, change in y over x. So the amount of plastic produced in the United States, no. The number of years it took, no. The average annual plastic in billions of pounds, the United States, nope. The average, oh yeah, it is this probably. The average annual increase in billions of pounds of plastic produced per year in the United States. No, it's D, sorry, it's the increase. This is not the average annual plastic production. It's not a constant, it's moving up. The average annual increase in billions of pounds. Which of the following is closest to the percent increase in the billions of pounds of plastic produced in the United States from 2000 to 2003? So 2000 would be 15. 2000. Oh, okay. So let's actually look at these data points. I think we don't want the line of best fit. They actually want to know 100, 2000, and then 2015 is, hold on, another 5 years is up to 20. Well, we don't know. It's just an estimate. Oh, I'm sorry, 2000, 2003, not 2015. 2000 to 2003. So it's like at 100 up to 107. So maybe like 7%. It's about 10%, I guess, is the closest. Yeah, I mean, that's the only thing, percent increase. I think that's what they're asking. 2000 to 2003. It's just a little, for some reason it's feeling a little confusing to me, but let's roll with it. The equation above models the number of members M of a gym T years after the gym opens. Of the following, which equation models the number of members of the gym Q quarter years after the gym opens? No, it's not A. So what they're doing is, hold on, let me think here. So it's 1 quarter, 2 quarter. No, it might be A actually. 4 quarters. So 4, when it equals 4, that's like 1 year, and that looks right. Although when we divide it, we have to modify. No, it's definitely A. A is the only one that makes sense, so that we don't have to worry about anything, because A is the only one. We shouldn't be multiplying by 4, because that would mean 1 quarter would be like 4. It would put 4 instead of, and then 4 quarters, which should equal 1 year, would be 16. That's not right. The only one that works is A. For the finale of a TV show, viewers could use either social media or a text message to vote for their favorite 2 contestants. The contestant receiving more than 50% of the vote won. An estimated 10% of the viewers voted, and 30% of the votes cast were cast on social media. Contestant 2 earned 70% social media and 40% text message. And based on this information, which of the following is an accurate conclusion? So the contestant read, an estimated 10% of the viewers voted, and 30% of those votes were cast on social media. So only 10%, so 30% social and text message. This is text message. This is 30, 70. And so social media got, let's say the contestant 2 got 21, right? 70% of that 30%, and 40% of that 70, which is 28. So he got like 40. Contestant 2 got 49. Contestant 1 looks like they won because they got 51 of the total. Viewers voting by social media were more likely to prefer contestant 2 than were viewers, not necessarily. Well, let's see. If all viewers had voted, contestant 2 would have won. No, that's not true, because we can see contestant 1 would have won. It doesn't matter. Assuming that everything kind of stayed roughly the same. Viewers voting by social media were likely to be younger. That's ridiculous. I have no idea why they said that. If all viewers who voted had voted by social media instead of by text, that's assuming that they would all of a sudden change their vote. I don't know if so look, viewers voting by social media were more likely to prefer contestant 2 than were viewers. I guess it's D. I mean, I'm not super confident about that answer, but it's the only one that makes sense. Population of Greenleaf, Idaho. The table above shows the population of Greenleaf, Idaho from 2000 to 2010. If the relationship between population and years linear, yeah. Which of the following function models population of Greenleaf 2 years after 2000. So let's do the slope. It's 862 minus 846 over 10 minus 0, right? That's the 2010 to 2010 to 0. And that's 62, so that's, what is that, 16 over 10. It's a slope of 1.6. Negative, of course, it's going down. I should have flipped this. It should be 846 minus 862. Sorry, so this is a negative slope. And these two are definitely have that negative slope. We're starting at 862. Oh, but this one was 16. It should be 1.6. This doesn't make any sense. It's A. Yeah. All right, cool. Next, 26. After we hit 30, they start to get easier. So we're just that's what we're shooting for. And if you're getting slowed down at this point when you're doing the test, you're not sure what to do, I say jump ahead to the free response. So those first 4 are going to be much easier than these problems. To determine the mean number of children per household in a community, Tabitha surveyed 20 families at a playground. The mean number of children per household was 2.4. Which of the following statements must be true? No, this isn't necessarily true because she's at a playground where obviously like everybody there has kids, otherwise they wouldn't be there. A determination about the mean number of children per household in the community should not be made. It's probably a pretty small sample size. I could go with B. A is out. The sampling method is flawed and may produce a bias. I definitely say this is right. I mean, I don't know if that, yeah, it depends on the size of the community. If the community's 30 people, it's not a bad sample size. Sampling method is not flawed. Yeah, that's definitely flawed. All right. 27. In the xy plane, the point PR lies on the line with the equation that where b is a constant. The point with coordinates this lies on the line with the equation this. What is the value of r over p? All right, let me think about this. The point PR lies on the line, equation, boom, and then that one lies there. So let me see here. How do I set this up? Oh, B is the same. So what we're trying to do is we're trying to solve for B and then set those two equal to each other. This is my guess. So PR. So I'm going to plug that in for the first equation. R in for the Y equals P in for the X plus B. So B equals R minus P. Okay, that's one part. Down here, we have 5R. I'm plugging it in for the Y equals 2 times 2P, plugging in that X plus B. Isolate, this becomes 4p. 5r equals that plus b. Subtract 4p, subtract 4p. 5r minus 4p equals b. Now we can set these guys equal to each other. 5r minus 4p equals, let's see, r minus p. I think I'm doing this right. I hope 3p equals, I'm adding 4p, subtracting that equals 5r. And we want to get r over p, so I'm going to divide both sides by p, and then I'll multiply by 1/5, multiply by 1/5, that goes away. So r over p equals 3 over 5. I think that's right. Ah, shoot, it's not there. Hold on, 4p. Did I plug in everything right? 5r equals 4p plus b. 5r minus 4p equals b. R minus p equals b. Hold on, 3/5, 3 over 5. All right, let me try one more time. I think these are correct. So then we have 5r minus 4p equals r minus p. We're adding, it's 4. Oh, it's 4r. I forgot to make that 4r. 4r equals 3p. Divide by p, it's 3/4. So then r over p equals 3/4. There we go. All right. See, it's important too. Not sometimes people get the wrong answer and they're like, I'll just choose the one that's closest to it. You don't do that because you must have made some sort of major mistake. You go back and see if you can work it out. The 22 students in a health class conducted an experiment in which they each recorded their pulse rates in beats per minute before and after completing light exercise. The dot plots below displays the results. It's like a histogram. Beats per minute after exercise. Okay. So it goes back out to these like regular resting rates, but I guess it kind of pushes everyone to the center. Oh, no. Yeah. But that's before they're all kind of like roughly here, and then after they've all spread out to these random ones. Let S1 and R1 be the standard deviation and range, respectively, of the data before. S2, R2, standard deviation and range of the data after, which of the following is true? Yeah, the ranges are not equal. So what are the ranges? So R1 is the range, R2 is the range. It's saying the ranges are equal. No way. A is gone. The range is here. This is 32, and this is... Oh, wait. The ranges are equal. 32 to 32. Whoops. Okay, so the ranges are equal. So it's either A or D. So the question is, does S1 equal S2? And we're talking about standard deviation. Standard deviation is just like how spread out the data is. We don't have to actually calculate the standard deviation because that would take forever. But look, clearly the standard deviation is not equal here. It's much more clumped together. Here, the data is much more spread out. So I'm going to go with D. And we'll double check if that is incorrect. We'll look a little bit more deeply. Maybe they did calculate it. I doubt it. But a photocopy machine is initially loaded with... This is one more question than we got for your response. 5,000 sheets of paper. Oops. The machine starts with a large job and copies at a constant rate. After 20 minutes, it has used 30%. After 20 minutes, it has used 30% of this is 1,500. Which of the following equations models the number of sheets of paper P remaining in the machine M minutes after the machine started printing? It's just 5,000 minus... Hold on. It's doing, after 20 minutes, it's doing 1,500 per 20 minutes. Cross off the two. It's 75. It's 75 sheets per minute. Right? That's basically what's happening. Because I calculated that 1,500 from the 30%. And now I want the per minute reduction. So every minute's knocking off 75. And we can check that by multiplying this by 20. And then we get back to 1,500. So this is our linear equation. And it should be, it's this guy. They throw some exponential in there, but they already said it's a constant rate, so we know it's linear. That's funny. All right, let's do number 30. Is this free response? No, it's not. Oh, I think, oh, maybe it starts at after 30. I'm sorry. At 31, we got one more. And we got function with x, that's f of x. Now this is another function, g of x. The complete graph of f and our table of values of g are shown. The maximum value of f is k. The maximum value of f is k. And k is right here. This is the maximum value, which is 3. So k equals 3. And now they want to know what is g of k, meaning when we plug 3 in for g, what do we get? Let's look at the function. Here's we plug 3 in, we get 6. It's simple as that. If you understand the function notation, it's pretty quick. Now we're back. Now these next 4 are gonna be pretty good. There are 2 atoms of hydrogen and 1 atom of oxygen in a molecule of water. How many atoms of hydrogen are there in 51 molecules? So 2. There are 2, and then we got 51. So 2 hydrogens in every water molecule. We got 51. Multiply it out to 102. X equals 1 in the equation above. What is the value of A? Oh yeah, just plug in 1. 1/2 A equals 0. 1/2 A. I'm moving the 1/2 A to this side equals 1. And then times 2 times 2, right? To get rid of the 1/2. And A equals 2. All right. Next, see how much better those are? And then we go in the xy plane, the equations x plus y to this and this represent the same line for the same for some constant c. The same line. What's the value of c? Well, they clearly equal each other. So let's do it like this. Let us isolate. Alright, I'm going to isolate x. So we'll say x equals 2y, negative 2y plus 10. And this one is 3x equals negative 6y plus c divided by 3. X equals negative 2y plus c over 3. So negative 2y plus 10, I'm saying these guys, this and this equal to each other. Negative 2y plus 10 equals negative 2y plus c over 3. Cross these guys out. C equals 30 because we multiplied the 3 over here. So c equals 30. All right. On April 18, 1775, Paul Revere set off on his midnight ride from Charleston to Lexington. If he had ridden straight to Lexington without stopping, he would have traveled 11 miles in 26 minutes. In such a ride, what would the average speed of his horse have been to the nearest tenth of a mile per hour? So miles, but it's per hour. So if we convert 26 minutes to an hour, we have to divide it by 60. Right, 26 divided by 60. 0.4333. I don't like to use a repeating decimal. So let's just reduce it. It's 13 over 30. Right? So then we just do miles 11 per hour, which is 13 over 30. And then we just gotta kind of multiply. So it's just the nearest tenth. So this goes here, this goes here. It's 330 over 13, and we divide 330 by 13, and we get 25.4 miles per hour. 25.4 miles. Oops. I put the wrong thing in. 25.4 miles per hour. Does that make sense? I'm going to do a gut check. Does that make sense? Well, in 26 minutes, he would have gone, that means in an hour he would have gone 25.4. Let's think about it. 26 minutes, he goes 11. 52 minutes, he goes 22. So, and then in the remaining 8 minutes, does he go about 3 miles? I'd say that roughly makes sense because, I'm sorry, 8 minutes, he goes 3 miles. That sounds about right. Right, 1/3 of this, 1/3 of this is about 3 miles. 1/3 of this is about 8. So I'm gonna say I feel good about that. Next, we've got this function. It says the graph function is defined as -1/2 times that whole thing. It's a quadratic shown in the xy plane. The function g, not shown, is a linear function. What's one possible value of a such that the two equal each other? So all we got to do is set these guys equal to each other. It's negative x. I mean, I could also graph this, to be honest. It's 10, and then it drops down like boom, boom, boom. It's right here. This is where it hits. Is at 3, because it's just got a slope of -1 starting at 10. So it's at 1.5. A should be 1.5. But I'm going to do it algebraically just to be safe. We got plenty of time. Negative x plus 10 equals -1/2 x minus 4 squared plus 10. These 10s cancel out. Negative x equals, well, let's go ahead and FOIL it. -1/2 times x squared minus 8x plus 16. And then actually no, let's not do that. Let's multiply both sides by -2, and we got 2x equals x squared minus 8x plus 16. Minus 2x minus 2x. 0 equals x squared plus 10x minus 10x plus 16, and then we're going to factor x, and we got 8 and 2 minus. So we got x equals 2, x equals 8. That doesn't make sense with what I just thought was right. So I thought it would be 1.5, 10. Oh, yeah, because I wasn't looking at the slope correctly. So because it is a slope of -1, so it's down 1 over 1, because 1 is different here. So down 1 over 1, down 1 over 1, and that's the 2. Down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. And there's the 8. So it's 2. But wait, what did they say? Just one value, right? Okay. Not that I needed to solve it algebraically, I just didn't look at the graph carefully enough, so you just got to be really careful with the markings. In the triangle RST above, point W not shown lies on RT. R. What is it? R. It's S up here. ST. This is clearly 13 because it's a right triangle. You could use Pythagorean's theorem to figure that out. But then it also says W is on RT. Let's just put W here. What is the value of cosine RSW? I'm going to put it in red for now. Of RSW minus sine of WST. Okay. So cosine of RS. So we want cosine of this angle. See, I'm just mapping it out carefully. Cosine of this angle minus sine of W of this angle. So cosine of this angle is going to be, well, let's assume that this makes a right triangle. I don't know exactly how they want us to do this, so I'm gonna kind of make a guess here. So cosine of this, let's pretend this is a right angle. I'm just gonna pretend for the sake of pretend. I feel like that's gonna work out. RSW, and we want cosine of this. So cosine is adjacent over hypotenuse. This would be the hypotenuse. So SW over 12 minus sine of this, which is WST. Sine is opposite WT WT over hypotenuse, which is 5. And they want an actual value. Oh my gosh. Okay. So let's see. SW and WT. So how would we do this? And what's the relationship between SW and WT is the question. Oh boy. There's something I must be missing here. It lies on RT, and we want cosine of RSW. 13, and it's 5. Okay, I'm gonna take some leaps here. I'm not actually totally sure how to do this, but it's usually like what we would do is say 12 over x equals 5 over, no, but we don't know what W is. It's 5, it's 13, 5 over 12. Don't, man, I am not sure. So SW, so it's this is, hold on, SW over that, right? So it's basically the, okay, let me try it another way. We're assuming that they're all right triangles and that they're all proportionate. So it's basically, it's little side, right, over hypotenuse. So we'll say little side over hypotenuse, we'll say, I'm taking a lot of leaps here. 5 over 13. So the ratios are the same regardless of the triangle. Little side over hypotenuse minus little side. Is it again little side? Sine of that is opposite over 0? I'm going to go with 0. I'm really not sure. So we will go with 0 and move on. And we'll just see the explanation. That was the toughest one I've ever seen for trigonometry. And maybe I missed something really easy, but I'm confused. All right, minutes after injection, penicillin concentration, microorganisms per milliliter. And we got a graph here, penicillin concentration as it drops over the time. Concentration, all right. So the concentration is decreasing in that way. When a patient receives a penicillin injection, the kidneys begin removing the penicillin from the body. The table and graph above shows penicillin concentration in a patient's bloodstream at 5-minute intervals for the 20 minutes immediately following a one-time penicillin injection. Cool. According to the table, how many more micrograms of penicillin are present in 10 millimeters of blood drawn from the patients 5 minutes after the injection than are present in 8 millimeters drawn 10 minutes after the injection? So we have 10 milliliters. So 5 minutes, let's see what happens. In 5 minutes, it drops by 25%. So we have 10, so we're down to 7.5. And then here we've got 8 millimeters of blood drop. Oh no, I'm sorry. 10. I'm looking at this incorrectly. Micrograms per milliliter. So at this point, at 5 minutes, we've got 150 and times 10, so we got 1,500. And in the other one, we have 10 minutes. So we got 120. Man, this is tough. This is hard to approximate from a graph. 120 times 8. Which is 960. So I think it's 540. Is there any equation? Because that graph is a little tough to totally approximate. Oh, here we go. Here are the exact values. I didn't see this. So it's 1520. Sorry, 1520. And then 118 times 8. 944. 6, 7, 5, 576. Yikes, I would have gotten that wrong too. All right. The penicillin concentration in the patient's bloodstream is modeled by this equation, and it says if P approximates the values in the table to within 10 micrograms per milliliter, what is the value of B rounded to the nearest tenth? Okay. So we've got that constant, and we want to solve for the constant. So P is the concentration. So let's just take a value that we know. Let's take this one. Let's take 118. Yeah, let's do 118 equals 200 times B, which is what we're trying to figure out. And then our T value is 10. Right, that's what I'm using. So we're just plugging and chugging. 10 over 5, right? 10 over 5 is just 2, so 200b squared equals 118. Divide both sides by 200. 118 divided by 200. 0.59, so 0.59 equals b squared, and then square root. Square root of 0.59 is rounded to the nearest tenth, 0.8. Well, I guess that's it. So it's 0.8. If you wanted to, you could plug it. You could actually rewrite the equation and test some values out. So it's like 200 excuse me, times 0.8 to the, let's try it for when t equals 20. Right? So to the 20 over 5, which is just 4. And we should get 74 or something. Approximately 74. It's a little off, but then we did round up pretty substantially. They want us to round to the nearest tenth. 100th, we get a better answer. All right, there's only 3 minutes left, so I'm just going to go for it. Let's see what happens, and not really going to check anything. I don't think we have a lot of time. All right, let's see what we got. I actually got them all right. All right, so I got to see this trigonometry one because that was a bit of a guess. I mean, I was making a lot of assumptions. Let me put it that way. Where is it? It's 35, right? No, 36. Here we go. So how do they do this? No matter where point W is on RT, the sum of the measures of RSW, WST is equal to the measures of RST. WST are complementary angles. Therefore, the cosine of one equals the sine of the other. Yeah. See, I just forgot that rule. So that's why I had to make all these random assumptions. And I guess I kind of figured it out, but if I would have known that rule, man, that would have been super simple. You don't always know the rules. I mean, I don't know all of them, but I know enough trigonometry, I guess you could say logic too, to reason it out. So that's it. This concludes all the SAT Khan Academy tests because we've gone through all of them now. And what we're going to start next week is doing 5 questions or maybe 20 questions. I haven't decided yet out of each category. So I've already gone through all the categories once. I've done 5, 5, 5, 5, 5. Now I'm going to do the second round, which is going to be a slightly higher difficulty level, and then the third round, and then the fourth round, because I think there's 4 sets of 5 in every single one. So that's it. We'll start with that next week. Thank you guys so much for joining. Please subscribe to the channel. It helps me out a great deal if you do that, and hopefully you will get a lot of value as well if you're prepping for one of these tests. You can check out our math music videos as well. And if you want to sign up for our mailing list and get free access to my multiplication course, go to scalarlearning.com and sign up there. Enter your mailing address. You'll get your email anyways, and you'll get the coupon code to get free access. That's it. Thank you guys so much for joining, and I'll see you guys next time. Take it easy.